Good morning, student. My name is Dr. Shivali Verma. I am Associate Professor Physics in Department of Basic Sciences. Today we have discussed about the formation of coherent sources and Young's double slit experiment. As you know that the formation of two coherent sources is not like that we can use two bulb or two tube light as a coherent sources, because when we are discussing about the production of light, the light is produced by the photons, and the formation of photons inside the bulb or inside any tube light or inside any conventional sources not generated at the same time. That's why the variation in the time duration and generate the frequency variations, and therefore two bulbs or two tube lights or two conventional sources not behave like a two coherent sources. I want to say one thing, that if you are using two sodium lamps also, and you want that these two sodium source behave like a monochromatic the coherent source, then only these two sources are not behave like a two coherent source. Because of that, because the time duration of production of photons inside these two sodium sources are never ever same, and therefore they are not behave like a coherent source. So there are few methods by which we can produce two coherent sources. So one method is by the division of wavefront, and second method is by the division of intensity. By the division of wavefront, we have used Young's double slit experiment, and for division of intensity, we have used two experiment. One is a Newton's experiment, and another one is the Michel's interferro. With the help of resonant biprism, we have also divided the wavefront, but it is not in our course. That's why we have not discussed it here. So today we have discussed about the Young's double slit experiment, in which we have divided the wavefront and produced the two coherent sources. So how this Young's double slit experiment produced the two wavefronts or two coherent sources, we will discuss now. As you know that what Young's did, Young's used a cardboard, and in which put two holes, two pin holes, and in front of that he used one source. And as you see here, that this source is producing the some wavefronts, and these dotted lines shows the crust, and this complete line shows the trough. So this crust, this from this source, the light is traveling in the medium, and when this wavefront strike with these two holes, they produce new wavefronts. Because by the theory of Huygens principle, we know that the each points of wavefront is able to produce new wavefront. It means that the each point of wavefront is able to generate a secondary wavelet, and that secondary wavelet is able to produce new wavefront. So on the basis of Huygens theory, here we have seen that two new wavefronts are produced, and when these two wavefronts are moving in a medium, they also produce they also generate trough and crust, and they travel in the form of trough and crust. Okay, so as you know that according to Huygens theory, the new produced wavefront having same frequency and same wavelength as the source have. So these two wavefront also having a same frequencies and same wavelength, and when this traveling in a medium, there are the few points where the crust is overlapping over the crust and trough is overlapping over the trough. As you see here that there are few points where crust and troughs are overlapped to each other. So when this crust and troughs are overlapped to each other, then on the screen we have find a bright fringe. Why? Because as we know that when crust is overlapping over the crust and trough is overlapping the trough, the intensity become maximum. But there are few other points where crust is overlapping the trough and trough is overlapping over the crust. So if we collect these points which where the trough and crust are overlapped to each other, we found that the intensity become minimum. Why? Because we know that the crust intensity and the trough intensity are the just at a 180 degree to each other, and in such a condition they have just minimized the intensities. Okay, so bright fringes are formed where the crust overlap over crust, or trough overlap on trough. And dark intensity, we can find dark intensity on that point where trough and crust are overlapped to each other. So in this way we find bright fringe and dark fringe. So this bright and dark fringes we are getting because of the interference of two sources which having a same frequency. And we have seen here that some places are the some places we are getting bright fringe, and on the some places we are getting the dark fringe. It means that with the help of this experiment we can perform the interference, and we can produce the two coherent sources. Okay. Now, in Young's double slit experiment, we can calculate the bandwidth and sorry, fringe width of this fringe. So how we can calculate this fringe width? So for that we can derive a derivation. So for this derivation we have supposed that there are two narrow coherent sources A and B, placed at a distance of 2d, and a screen is placed capital D distance away. So there are two sources A and B, and both are very narrow sources, and both are placed at distance 2d, and a screen placed far away from these two sources, and the distance between these sources and screen is denoted by capital D. If two rays AP and BP are reinforced at a point P, which is on the screen, then we have to find out the path difference between AP and BP. First we have to find out the path difference, and with the help of this path difference we can find out the fringe width. So what is this path difference? Actually this path difference is a path difference between the two light ray, and we know that A is near to the P and B is a little bit far away to the P. That's why there is some difference between the AP and BP. So we are calculating here the path difference. So path difference is denoted by delta. So delta is equal to BP A minus AP. Okay. Now how we calculate this AP and BP? So for this we have formed a triangle here. So formation of how we can form a triangle. For that what we are doing, and we are just draw a perpendicular from A to screen which meet at a point M, and B to screen which meet at a point N. So we have drawn two perpendicular AM and BN. Okay. Now we have considered a point on a screen which is O, and this point O is having an equal distance from A and B. That's why the light ray which are coming from A to O or B to O having a same path, or we can say that the path difference is 0. And in the condition of interference, as you know if we are talking about the generalization condition of interference, then we know that the path difference delta is equal to n lambda for the constructive interference. So in this situation where the path difference is 0, it means that the value of n is here 0. Therefore the delta becomes 0. Therefore this situation where the rays coming from A to O or B to O, so in this situation at O the intensity is maximum, or we can say that we have find here a bright fringe. So this position is for the bright fringe only, but we cannot we do not know the color of the fringe which is situated at a P. So we have just think that from this position from O to P the distance is X. Okay, and now we have one triangle A M P and another triangle B N P. Okay, so as you know that as you see here, both triangles are actually a right angle triangle. The AMP is also a right angle triangle, BNP is also a right angle triangle. So if these two are right angle triangle, then there is a possibility to calculate the AP and BP with the help of Pythagoras theorem. So as we know that for the Pythagoras theorem we have to know the value of a perpendicular base and hypotenuse. So as you see here that AM, which is the base of this triangle, is equal to D. Why it is equal to D? Because we know that the distance between the source and screen is a D. And if we are talking about in this rectangle triangle, rectangular, then we have found that AM is equal to this line and this is equal to D. Therefore, this AM is also equal to the D. Similarly, in this triangle in BN, and the distance is equal to the D. So now we know the value of base in both the triangle. Now we are talking about the perpendicular. As we see here that AM is a perpendicular in triangle AMP. So how we calculate this PM? As you see here that the distance between A to B is 2D. So if we are considering a point which is just in the center of A and B, then suppose that this point is O1. This point is O1. So in this condition, the distance between A to O1 is small d, and O1 to B is also equal to the small d. So if we are talking about in this rectangular AO1 OM, then the distance between AO1 is equal to MO, and this is also equal to the D. Now we want to calculate what? We want to calculate the PN. So as you know that the distance between O to P is X and the distance between O to M is D. So what is the distance between P to M? Quite obvious. This is X and this is D. Therefore this distance is X minus D. So the distance between P to M is X minus D. Now we have calculated the distance between P to N. So the distance from O to B is D. Therefore, the distance between O to N is also D because they are the side of the rectangle. So this distance O to N is also equal to the D. Now P to O, the distance is X, and O to N distance is D. So what is the total distance between P to N? X plus D. So the value of P to N is X plus D. So in this way we have the value of base as well as we have the value of perpendicular. So now we are calculating the value of hypotenuse in both of the triangle. So first we have calculated the value of AP. So for that we have calculated what? We have calculated we have applied the Pythagoras theorem in AMP triangle. So we are talking about the AMP triangle. So in AMP triangle, what is our hypotenuse? AP. What is our base? AM. What is our perpendicular? PM. So AP, what is AP now? AP is equal to D square plus D square square plus X minus D ka D whole square. Okay. So see here AP is equal to D square plus X minus D whole square, and this is our first equation. Similarly, we have calculated BP. So we are talking about this triangle now, BNP, and in this triangle BNP, the BP is a hypotenuse. So BP square is equal to D square plus X plus D whole square, because D is our base and X plus D is our perpendicular. So this is my equation number 1 and this is my equation number 2. So because we have to find out the BP minus AP, therefore we subtract equation number 2 from equation number 1, and what we get this equation. So after substituting the value of BP and AP square, we are getting D square plus X plus D whole square minus D square minus X minus D square. Now whatever the things are going to be cancel it. So D square is cancelled by D square. When we open X plus D whole square, where we get X square plus D square plus 2xd, D minus X square minus D square plus minus 2xd, and when we cancel out this X square by X square and D square by D square, what we will get? We will get 4xd. So what is the value of AP square minus BP square minus AP square? It is equal to 4xd square, and this is our value. Now what we want AP minus BP minus AP, and we get here p square minus ap square. So again we open this by the formula of a square minus b square. So according to that formula, a square plus b square is equal to a plus b, a multiplied by a minus b. So with the help of that formula, we open this formula, this bp square minus ap square. So we get this bp minus ap multiplied by bp plus ap is equal to 4xt. Now what we want only bp minus ap. So we leave a 4xd here only and take it here, this bp plus ap here. So now our situation is this, and this bp minus ap is a part difference, that's why we replace this by delta. Now what is the main thing? The main thing is that I have substituted the value of bp and ap both d, so that I will get this value 2d. Now how we will get this value 2d? So as you know that whenever the things are situated, when the 2 points are very near and one point is very far away to them, and if we are tracing a line in on that point, then we will find out that the angle between this distance, this angle is very narrow. So if this angle is very narrow, this angle is nearly about theta, or this angle is also very narrow, it is also theta, then in this situation, whatever the distance is here, suppose that this is a point, and the light rays reinforces on a b point, and this is the c point. So c and a are very nearly situated, and b is very far away from c and d. So in such a condition, the distance from a to b or c to b is approximately equal to cb, or approximately equal to ab. Okay, so if suppose that this distance is d, so in that condition ap is also become a d, and this cd is also become a d. But take one thing in your mind, that these distance are approximately equal, but there is some difference, so that we cannot say that bp ap is totally zero. It is not totally zero. There is some difference, some fraction of difference are present, therefore we cannot say that this is totally zero. But in the additional condition, we can say that these distance are approximately equal. So as we know that the value of bp and value of ap, bp like that, I'm again tracing the diagram, that suppose that this point is a, and this point is B, AB, and the distance between the BP and to this P point is approximately, it is equal to D. So these 2 points are very nearly situated very near, and AP is very far away from the screen range. So this is, if this distance is D, then we can say that this is also D and this is also D. So at the place of AP we can put D, and at the place of P we can put D. So in this condition we get what? 2D. So what is our delta now? 1, 2, 4 is cancelled by this 2, and we get here 2. So the part difference is 2xd by capital G. So this is our part difference between the AP and BP. But what is the color of fringe? We don't know. So we have supposed that at the point P we get a bright fringe. So as we know that in the condition of interference, constructive interference, the part difference is equal to the n lambda. So if we suppose that the part difference between AP and BP is formed a bright fringe, so in such a condition this equation number 3 is equal to the equation number 4. So we equate this 2, and we will get t 2xd by d is equal to n lambda, and from this we calculate the value of x. So with the help, what is x? X is actually a distance between O to P. So this situation gives us the value of x. If the value of x, it means what? It means what? That x is equal to, if the value of x is n lambda by d by 2d, it means that the color of fringe at P is a bright. Right now, when the dark fringe is formed, for what distance the dark frame is constructed? So We have again talking about the path difference. The path difference is 2xd by d, but in the condition of dark fringe or in the condition of constructive interference, the path difference is 2n plus 1 lambda by 2. So if we suppose that at the point P the fringe color is dark, then in this situation the this path difference and this path difference must be equal. So we equate this two and we get the value of x. So what is the value of x? 2n plus 1 lambda by 2 by d. It means that if the distance from O to P is equal to this x, then the color of fringe is dark. Now as we know that in the main aim of is this derivation is finding the fringe width. So what is the fringe width actually? The fringe width is the distance between the two consecutive dark fringe or a two consecutive bright fringe. So now we are going to calculate the fringe width for Young's doubles, right? So if we suppose that we have taken 2 points, one is a xn plus 1 and another one is a xn, means there we have supposed two distance from O. One is at a xn distance, one point at a xn distance where we get the one bright fringe, and another point at xn plus 1 distance. Okay, so what is the value of x and xn for this dark fringes? For the dark fringes we know that at x the value is for xn the value is 2n plus 1 lambda d by d, but for second consecutive fringe the value of n is changed. Now the value of n is n plus 1. So at the place of n, if I substitute n plus 1, so what happened? We have to be multiply this by 2. So we get what? We get 2n and we get out 2n plus 2. Okay, and already 1 is also present here. So 1 plus 2 is equal to 3. So what we will get? We will get 2n plus 3 lambda by 2. Okay, so at the position x n plus 1, what we will get? We will get 2n plus 3 lambda by d by 2d. Now what we will do? We have just cancelled the things, and by the cancelling this all things, what we get? 2n 2d is cancelled by 2 and 2d, and 3 lambda d is subtracted by 1 lambda d. So we get what we will get? We will get 2 here, and I forget to write here 2 because it is a 2 here. So here also you can write down the 2, here also you can write down the 2. So what we get? 2 lambda d by 2d multiplied by 2. So this 2 is cancelled by this 2, and what is the final fringe width for the dark fringe? It is lambda d by 2d. Okay, so this is the fringe width for dark. Similarly, we have calculated the fringe width for bright fringe. As you know that for the bright fringe, the value of x is n lambda d by 2d, and the consecutive fringe, if first fringe is situated at n position, then second consecutive fringe is situated at x plus 1 position. So at the place of n, we have written here n plus 1. So now we are going to subtract this 2 xn, the position of x n plus 1 minus xn. So what we will get? We will get lambda d by 2d. So in the both of the situation we get the fringe width lambda d by 2d. So here we have seen that in the condition of Young's double slit, the fringe width is equal to lambda d by 2d, where d is the distance between the screen and a source, 2d is the distance between the two sources, and lambda is the wavelength of incident ray. The fringe width is denoted by x bar. So I think so it is enough for today. Thank you very much.